you see my screen?
Mm-hmm.
That's
Okay.
a fun program.
Hmm?
Just joking with you. So.
Okay, so what I'm going to be sharing with you guys today is this package called Dynashape.
Mm-hmm.
It's basically a form finding, it's an open source form finding plugin for Dynamo. And it uses physics simulation. I'm sure it's pretty similar to Kangaroo as well. We can just play this video so you can see what kind of things it does. This looks things like that. Yeah, just a very quick video. And the package is available on, you can get it off the Dynamo package manager, the website, or you can get it on GitHub at this path. When I do edit the videos, I'll put all this information on there as well. Okay, so let me just show you some sample files, and you can see this again, hey, in the Dynamo. Okay, so for this first one is called hanging chain. So to execute it, I just need to make sure that this is on automatic at the bottom corner there. And I just set this to false, reset to false. And you can see things like this. So it basically simulates a catenary structure. You can see that. So yeah, so that's just for a chain. So this node here is the solver. This is basically the engine. And all this operation here is you setting up the anchor points, the endpoints, and all the other good stuff. But I'm going to talk through one of the scripts I've made so you can get more detail out of it. Okay, so I'm going to open another one. Okay, hopefully So one weird thing that happens in Dynamo is even if you've opened another file, it still leaves the other one shown. It's so strange.
Yeah, it's closed.
It's closed. So I think the engine still has it saved somehow. So let me see. Yeah. So what I have to do now is I have to reset, and I have to put the execute to true, fast display to true, and then I set the reset to false. If it doesn't work, I'm gonna have to close Dynamo and open it again. One I should actually show you is this constant pressure. Really like that one.
Sounds like architecture.
Okay. So constant pressure. It is. Okay. So I'm just gonna set these to. I'm gonna set reset to true, execute to true, and then possibly then that as well. And then I'm going to set this reset to false. And then what happens, it starts to create that structure. So this is basically if air was pumping through and you had all these anchor points, you see all those anchor points there, right? And this border, what happens to the fabric when there's constant pressure being applied to it? And the cool thing is you can see that simulation of it as well. It's absolutely very responsive, very fast. You know, it's much faster than normal Dynamo geometry. And then you can also go to, I think it's this value over here, and actually apply more pressure. And you can see that over there as well. Very, it's just like, it feels like a game to me. Yeah, really.
You set the elasticity or the strength of the.
Yeah, so I'm guessing that because I haven't really so I haven't really experimented, understood particularly the material qualities, but I'm guessing this is what lets you play with that kind of thing. Yeah. But I need to go a lot deeper into it. Okay.
Because it looks like the goals are the parameters influencing structural elements or the development of the mesh itself.
Yeah, so the goals are from what I've worked with are the anchor points, right? So basically the goals are where does it need to attach itself to. So you can see those anchor points over there. They're holding it down, and the perimeter. So those have been the goals, right? So yeah, basically. Well, let me show you the one I made. My friend, he's from Botswana. He wants to build a market over there, and basically we thought about making it a temporary structure. Can you guys still see me, by the way? You only see my screen.
Right. Yeah.
Yeah, we can see
Okay,
you.
because I can't see you now. So we basically decided that it should be a temporary structure, and so the temporary structure we decided to make just for a proposal is a tented structure. And so I decided, okay, let me just play with this package called Dynashape, and this is what I came up with. So I'm just going to run it again. It is what you saw in the Revit window previously. So I'm just going to make this automatic over here. All right, and then I'm going to set this to true. Execute to true. Grasshopper just I'm sure handles this like so easily. Okay, and fast display to true over there. So what you see is this is the first layer, right? So this is basically the cloth. You can call it the cloth that then gets pulled over to the anchor points. So what I have is I have about 12 anchor points on the base, at the base, and then I have 6 anchor points at the top here. So you see these black dots, right? And then when I say false to reset, then it comes up as that. So this is a structure I came up with. So yeah, it does the same kind of simulation. So basically these entrances here become, these arches here become where people access the market through. And then when you look on Revit, it's a 500 meter long site. I hope he gets money to actually do this. Yeah, so I have basically how many copies here? About 10 copies, and there's a train line that runs between them. So there are two. So the idea is to use abandoned government land. So you can imagine something like this being built all over the country if it's a success. So that this is the idea is to propose this to the government. Then I can also actually show you where the site is just before we go into the script, so you get an idea. So yeah, this is what it looks like.
Wasted space, actually, like most infrastructure.
Yeah, so he has this drone shot of it. This is central Gaborone. You see the train lines over there, and this land parcel is about almost 20 meters across. So I have the first portion. It's 500 meters long, running here, and the other one running along here. Yeah. Okay. Yeah, there's nothing much else to see there. Okay, cool. So now let's get into the Dynamo script.
There's also a question in Revit.
Yep.
What material is that, or what family is it for the tools that structure?
Okay, what family is it? So I had to push this into Revit as masses. So first I had to split it up. Revit didn't want me to take it in as a full thing. Because you know how Revit is with all these kind of very. So let me take this.
Very fussy.
Yeah, very fussy with these kind of structures. So I had to pull it in. I had to explode the surface, right? And then the exploded surfaces I then pushed in as masses, and then I could then apply actual Revit. Only a wall was going to attach to this, so I had to use a Revit wall, a very thin Revit wall that I gave a canvas
So,
material.
ceiling didn't work of the layers.
So a ceiling, you can't actually apply ceilings to surfaces. You can only apply walls by face.
Yeah,
And
I thought you
then
can do a roof by face.
I did a roof by face, but did not work. Yeah, I don't know why. So I took walls. It works as well. I mean, it's fine. It's not bad. You can still,
That's
you
good.
can,
That's good to know because I've
yeah.
tackled requirements I know as well, same thing I'm used to.
You can still apply if you wanted layers to it. You can still apply that. You can still, schedule it the same way. It's still a BIM object. You can still do things with it. So, yeah, I was happy with that. You can see how large these things are. That's how small a bicycle is over there. And yeah, you can see some people in there as well. Yeah, cool. Okay, so let me just talk you through the script as quickly as possible, and hopefully Gerald can show us some cool stuff, cool stuff as well. Okay,
Yeah,
so
come
what?
No pressure.
No, I'm showing. Okay, so I'm just gonna set this to reset to true. Yeah, then I'll just take this. I'll freeze everything in here, so then I can start from scratch. I'm just literally gonna copy this, and then I'll explain as I go along. Okay, and I'm gonna hide the preview. And I click on the node. I'm just gonna hide the preview of that. It's not hiding it now. Preview. Okay, strange. I'm just gonna select everything then. Dynamo is so slow. And my computer is powerful, eh? Yeah, it is like 32 gigs of RAM and everything. Still, okay, that thing does not hide, but that's okay. We'll just work through it. Okay, so the first thing I had to do, I'm just gonna copy these first. Control C, Control V, and I'm gonna take it up here. I'm gonna unfreeze. Unfreeze that. Then I'm gonna show the geometry. Okay, great, it's hidden now. Okay, so the first thing I had to do was create a rectangle. Okay, so basically something I can parametrically change its width, and also change, this is the wrong way around at the moment, length and width, but you get the idea. So what I did here, I think I've shown you guys this before. It's called Dynashape. It's Dynamo's built-in coding scripting language. It's very similar for me, very similar to JavaScript. I did JavaScript last year. And when you do comments like this, it's kind of similar way it works. So then up here, we basically have the inputs, right? And the length. So when you do that, it allows you to add a number slider and attach it to those inputs. And then I have the base rectangle, and I'm basically then calling on the function rectangle by width and length, and then I input the width from there and the length as well. So if you search here, rectangle dot by width length, right? It's basically the same thing in design script, right? And the order at which you assign those parameters is the same as well. So if you wanted to use design script, all you have to do is copy what the node says and write it like this in this format. It looks like complex coding, but it is really not. You just need to understand that it's copying what the node is doing right back over here. Okay. So then what I had to get next was the curves of the rectangle So to do that, I had to explode the shape, right? And then I wanted to get the curves parallel to the x-axis. So then I asked for the direction of the line, because I wanted to use those two lines along the x-axis as the points where I placed the anchor points, as the lines where I placed the anchor points, right? So then afterwards, I just quit the design script. Then I just moved on to this one over here. I'll just see Control V. Okay. So what I'm getting here, when you get the line direction, you're getting vectors, right? So, and then I input those in here. And then it also needs, what is this? It also needs the curves of the rectangle. Okay. Okay, so I'm just going to explain this. So I don't know if you have a dot product in Grasshopper. Okay. So the dot product is what lets me know which curve, what direction is parallel to the x-axis. So if it's parallel to the x-axis, you see here, if it's parallel, I'm not sure if it's parallel or perpendicular. I can't remember which one now. But if it's parallel or perpendicular, you get a 0. So in that way, you can then filter out which curve is parallel to the x-axis or not. Okay. Then you then take, you then use a Boolean. You get a Boolean values. Which one is equal to 0? So basically, I'm getting the number. So this is a variable number. Num is a variable. Then I'm asking in design script, is it equal to 0? Okay. If it's equal to 0, it will give me true. If it's not, it will give me false. Right. And then there's now a function called filter by Boolean mask. So you're using the true or falses as a way of filtering out what line is parallel or not. So then at the end, it gives you two lists of in and outs. So whatever is in is true, whatever is out is false. Okay. So then if I go in here, let me just put another. Here, I'm going to hide the preview here. Okay. Okay. You see, so the ones that are true are the ones that are perpendicular. So then the ones that are out are the ones that are parallel to the x-axis. Okay. So now I've gotten those two lines. And the next thing is to then create the anchor points. So I'm going to copy this again. It's going to go up here. So what this then wants, it wants the in curves, the out curves. Okay. And then it wants the number of points I'm trying to create. So I'm just going to show the preview. Okay. And then the number of points, I think it's that one. So this one is the amount of anchors I want, which are basically the number of points. And then I'm basically going to take that in here. It's the same thing. And so this node here is from a package called Launchbox. I think you have that it's in Grasshopper as well. But they discontinued it, so I'm using the old version. They always so what we do in Dynamo, we have other packages called Pattern Toolkit if we were trying to create patterns and that. So it's all right. So what Launchbox gives me now, it gives me those anchor points. It also gives me planes, which I don't really need. I don't need those. All I need are the points.
I don't think Grasshopper gave you those planes, if I'm mistaken. Yeah, rolled a lot of curve into points, but I'm not sure if it would make you guys to use it when within the axis.
Yeah. Okay. And so this here is I labeled it so we can understand what it is. So this is from the Dynashape package. It then converts those points. You can see that here they're in a list. Oh, they're actually 7 points. 1, 2, 3, 4, 5, 6, 7. Because I divided the line into 6 parts. Okay. Yeah. Makes sense? And so then it converts those points into goals, the anchor goals. So basically those points that you saw my first shape attaches to on the ground, right? So it takes those points and uses them as the anchor points to hold the tent down. Okay, so great. So that's the Dynashape package. Then the next thing is to create, I'm going to copy this here. Let's see. Okay. Let me just see what this is collecting. Okay, so this one wants the, oh yeah, so I'm taking the in points here, the in lines. Okay. And then what else am I getting here? I'll explain shortly. I'm also getting the ins over here. Okay, cool. So I'm getting these, those two lines at the end. Let me just show you the preview again. I'm getting those two lines at the end because I'm trying to get their center points. So preview. Okay, so you see those two dots over there? Because I want to use those two lines at the ends to create the center anchor points. I want to use them to create the references for the center anchor points. Oof, why is this hanging now? Please don't crash, please. Okay. Oh, it's my autosave. I have this application called autosave, so you don't lose work. So immediately just...
So you should be happy, actually.
But I don't need it now. Okay, so then at those points, so these 2 points I'm showing you here, I'm getting the coordinate system along that line. Okay, so the reason I want the coordinate system is I want to get the x-axis of that coordinate system. So I want to offset in. You remember my shape had an offset if you look in Revit. The points are actually not on the edge, they're pushed in, right? So I want to get that coordinate system, and so it helps me create an offset into the rectangle. Okay. Okay, so when I get that coordinate system, this actually doesn't have any geometry, right? It's just a coordinate system. So then from that coordinate system, I get the x-axis, and I use that x-axis to offset those points in. But by default, the vector that I get, so you can see in here, there are 2 vectors. The vectors I get are pointing outwards, so I need to reverse them so they point inwards. You get that point?
It's interesting that when they both point the same direction.
So yeah, they're both pointing outwards.
So it's relative to your origin, that's why they're pointing outwards.
Relative to the curves.
Okay.
So not so the coordinate system, so this curve dot coordinate system at parameter. So the parameter is the parameter is 0.5, which is that center of the line, okay? And so the coordinate system is at 0.5 on the line. So it's not relative to the origin, relative to the curve itself.
Yeah.
Okay.
So I'm just thinking in terms of direction, I would have thought they would both point the same direction.
Yeah, so they are pointing in the same direction, outwards from the rectangle. I mean, which is, yeah.
So it understands that it's part of a bigger geometry.
Yeah, it understands it's part of, which is good because then I don't have to do any other coding. So then I reverse it, then it points back inside the rectangle. Okay, then the next thing now is to translate. So I'm going to show the preview. So translate in, I don't know if, I can't really recall now, I haven't played with Grasshopper in a while. So translate, I don't know if it's the same thing in Grasshopper. To move something, it's called translate in Dynamo. Okay, so then I use those vectors that you see here, that we created here, to translate the points on the ends inside. So those are the 2 points you see over here. You see, okay? And then...
Did you guess that distance, or did you try and get it exactly?
Oh yeah, sorry, the distance, there's a, I forgot to explain that. So I'm getting a distance from, I need to plug that in. Okay. So I'm getting the distance as width divided by 2. Okay, width divided by anchor number minus 1. I can't remember why I made I did that. Did the exact math, but there was a reason I did that. There's a very, yeah. Why did I do that? Anchor number minus 1. Okay. Yeah. Okay. But there was a reason I did that. So there's math in there, based off design script, and I input that over here, and then I took the direction from this over here, and the geometry I'm plugging in from where the points. So these points over here that I got previously. Okay. Let me know if you're not following, so I can slow down.
Recognize some of the principles, started playing around.
Oh yeah. Cool. Okay, then now from those 2 points, I create a polycurve. Okay, you see those? So then I connect a line. So that line will now be the reference I use to create the top anchor points. Okay, and then I divide that line itself into 1, 2, 3, 4, 5, 6 points. 1, 2, 3. Yeah, yeah. Okay. Then, okay. Sorry, I need to move this up because it's gonna block our way now. Okay, so now this is where it gets a little annoying at this point, because what happens is, and I don't know why, it doesn't make any sense to me. Maybe that's how it had to be done. You need, from that point, you need to start picking each point, each anchor point, and adding it to a list before it enters the solver. So that, for me, that's not really a parametric thing. It becomes a very manual task because I can't decide that I want this shape to have 20 entrances all of a sudden. If I wanted to do that, I have to start picking each point manually, right? So that's, for me, that's not great. So then basically now we have to get one of these. So I called it create suspension cable. Create suspension cable 1. So what that is going to do is basically going to create a vertical. It's going to push one of these points upward, and then you can use that as another anchor point, right? So let me just copy all of these. Yeah, this 1, 2, 3, 4, 5, 6. Yeah. Okay. Okay. Copy it up. I'm going to take all 6 of them. Okay. So I'm not going to try and attach that's a lot of. Okay. All right. So what we then need to do now is get the points from there into these points here. So so this is very similar to Python in that you can get a value from a list by referencing the index, right? So you just say point. So this is basically the list that I'm pulling, and then I say at index 4 because I know if I come in here in this list, I know there's 0, 1, 2, 3, 4, 5, right? So yeah, and the same way it works in Grasshopper, the index always starts at 0, obviously. And then basically all I have to do now is just plug these points in to there. Oh, have I done it all? Oh, okay. Great. Okay, so then I basically need to show let me just explain one of them. Okay, so I get these points, the first point, right? And then I translate it, which is move in Dynamo, on the z-axis, right? I do not really need to place this in Dynamo because by default, there's already the Z direction is already placed in there as a default value. But yeah, I just do it anyway. And then, so I translate.
This question, the native Dynamo, does it have a Z direction or Z direction component as well?
It does, so I can find that. But I like to type. I like to I like to do the design script. So vector dot z. So you see here z-axis. It has no inputs because obviously it's already there are no inputs on the side. You just need to take that, plug it in here. There we go. I can just delete that. Okay, so I'm just going to show this preview. Okay, so when we do that, we then get this moved up. So this first point moved up, and then we then translate it again. I'm going to explain why. Show it here. Where is that preview? Okay, up there. So the thing with the stretch, I'm going to try and explain this. To stretch the tent, there's basically a first point where in theory, where the fabric lies, it sits on. And then afterwards, you need another point that picks it up to its destination. Do you get that? So it basically drapes over it first, and then to get the tension in, you pull it again. That's how I get it. That's how I understand it. So that's what gives it the tension. Okay. So then that first point where it lies is the first height we placed. Then the next one is that point over here. Okay. So that's how it works. And then I then create from there, I create anchor goals off the first point, right? And then afterwards, you change the anchor goal. So you change it from that first point to the final destination. That's what this node does. Okay. Okay, then let me try and explain the others. And so you saw the colors previously that you in the first before I ran it. So those colors get created by this geometry binder. It's called a binder, a line binder. So basically that's skin, right? Those colors, and this is the RGB value in there. So this is a design script thing here. So you can say, I can find that as well. Color.by ARGB. And sorry, typing incorrectly. By ARGB over here. Okay, the same thing over here. So basically you have the alpha channel, which is 255, and then the red, the green, and then you have the blue. Okay, pretty simple that front. Oh yeah, the alpha is for transparency. Yeah, correct. And then what else is here? Let me just see what this is. Translate. Let me read this here. Then go change. So then it's basically the same. You have to repeat that twice. I can't particularly remember why I had to do that. But basically, you need to have those two components. So it's for the first one. So from the first point to the other point, right? And from this point here to the final point. So we have those two goals, and we add them in here before adding it into the final destination, which is over here. Okay. Okay, so that is basically it. And then we have, after that, we create a rectangular grid as well. I'm kind of confusing you now. But I think basically this is where the bulk of the work is. Okay, so we don't. This here as well is very important, but I'll just explain it off my first script. Okay, let me know if you're confused. You're getting it.
All good at the moment.
Okay, so from your dimensions, you basically then need to create a rectangular grid of points. So I'm just going to show this preview. Okay, so but this is based off the one over here. Okay, so I think I should just actually copy it. Let me not be lazy. Okay, it's getting too long. Control C.
Also call it UV or
UV. No, so this is not a UV because there's no surface. Okay, let me just copy this. Control C, Control V. Okay, I'm gonna place it the same way as well. So basically, to create the rectangular grid, I'm gonna unfreeze it. To create the rectangular grid, we need the length x in the x direction, which is, if you look here, is the width and that length. Okay, so basically the same. Hello? Hello? Gerald, sorry. Gerald, are you stuck?
Yeah, I think my internet is
okay. Your internet
acting weird.
Okay. Cool. And so we basically get those two lengths, and then it asks here for the divisions. So basically, how many points along the x and the y axis are we getting? And then here we just get the x rows and the y rows. Okay, and we input it into this here, which joins them as a list. Okay, it puts them together in one list. Okay, and then afterwards, I'm just gonna copy this as well. Control C, Control V. I need to take all of this in. Okay. Let me just get those length values correct. X length, Y length. Okay, so I think the X was the width. Alright, that should be it. Okay, so I'm just going to take over here. Alright, that. And then the Y. I'm going to get off here as well. And the reason I place my inputs so far, I just like my inputs in one place, but sometimes not very practical. Okay, so I need to hide this preview so it stops overlapping as well. Okay, are you following? Okay, so then it then wants us to create the goals to force the membrane to maintain its natural dimensions. So these are two Dynashape nodes. So all you have to do there is basically what you see on here is you get those points you've created as a list and you plug it into that node. So I'm going to just take that from here and I plug it in over here. Okay, let me just see the preview. Okay, and so what it creates, it then creates that. Just hide the preview here. And it then creates that shape, as you can see. Okay, and then it then creates constant goals to simulate gravity acting on all nodes. So then it's what it's asking for. It's starting positions. So it wants it wants everything that is within here. So it's all. So I'm going to take the all, which is over here, and just plug it in over here. And I'm going to show the preview as well. Okay, I think that's right. Preview. Okay, so these as well are also Dynashape elements. Okay, so this is what if you remember previously, this is how the gravity, basically the force of gravity, from what I understand, acts on the overall shape. Okay, so then from then on, you need this here for visualization. Okay, so what I'm getting here, it wants the vertices, which are from our list join. So what I got, so this list join here, it wants those vertices, and we plug them in here. And then I'm just going to try and see a preview. Okay, doesn't show us. Also, the preview gets done in the final engine. Okay, so this is just like the precursor to that. So for the visualization. So then after that, basically after creating this entire mess of stuff, you then plug it into this first list, which is for the anchors. Okay, so those points on the horizontal plane, and those points that have been raised up, and then you add what they call the binders to this list as well, and then you plug them all in here. So in the solver, basically to instantiate the solver, the engine, you need this solver.create. Okay, and then you need to have the goals, which are those anchor points. You need to have those anchor points in one list. So I had to flatten this list. Okay, in Grasshopper you can easily flatten a list by using what's it called? At the end of the node itself. But Dynamo you need this flatten. Okay, so that's one advantage of Grasshopper. One thing it has over Dynamo. And then there's this thing for iteration. It's almost like generative design, where to get a more accurate result, you need to iterate, increase the amount of iterations. But for my computer, I don't want my computer to freak out, so I can even leave it at 0 and it still looks fine. I don't really need it to do that. And then before it actually runs the shape, you need to set reset to true. Okay, then execute needs to be true. Okay, when you then do that, you then set it to false, and then the shape does what it needs to do. These momentum I don't really get yet. So if you see enable momentum, it does give you a explanation. Apply momentum for the movement of the nodes for simulation of physical motion. Okay, so that's what simulates the physical motion. And fast display. Okay, fast display, I think it makes it display much faster from the name. And then manipulation basically lets you do the pushing and pulling that you saw me doing previously. So I'm just gonna hide all what I just made here, and we can just run it again. Okay, it's a Dynamo freaking out.
What are your architectural fees on this?
On what?
On this project?
No, it's free.
It's
It's actually free. I'm trying to we're trying to see if we can get funding. And if we get funding, and sure, then we can start to talk architectural fees. But for this, it's very free. Yeah, I can't afford it, unfortunately. Yeah. Okay, so now let's see what happens when we try to run this guy. What else did I freeze over here? Okay, I froze this one over here. On freeze. Okay, then that the base mesh shows up, and you can also see the verticals. You see those points? It creates those points as well. So basically, the first point at which the cloth is going to sit before it gets pulled up to that point I spoke to you about earlier. Okay, then I have to reset this to true. So I've already done all the settings, and then if I set this to false, the shape should get pulled up like that. Yeah, it's much faster than Dynamo geometry. I'm very happy about that. I mean, if Dynamo had to do this with its geometry, it wouldn't happen. It will not happen. Oh, excuse me. And so, yeah, basically what it is. And so what I noticed, initially it failed when I was trying to do it, but then I realized it wants all your points. That's why I had to do the previous math you saw. It wants all your points to lie on a line, right? If it's lying at the center, it doesn't really work. Yeah. So you need to work out the math based on your divisions. That's what I noticed. It didn't work when I did it any other way. Based on your divisions, you need to know that it's going to sit at one of those intersections, or else it just doesn't work. It kind of makes sense, I guess, yeah, so then you can see what's interesting is the way these lines point out. That's what happens on stretch tents, if you've noticed. So when they you try and poke a pull through them, it kind of acts against it, and you have to pull it in that direction, right? So it's showing you the direction of the vector that you're going to get. So it's really simulating how this thing is behaving. And when I pull it, you can see how it's behaving over there. So then I actually got those directions. I'll show you later on. I got those directions and I used it to plot where the post would be in Revit. I projected that line onto the horizontal plane, and I used it to create the poles in Revit. So let's see how that works. So when I'm going to go back into over here. So to show the actual Dynamo geometry that you can then carry on and push into Revit, you then have to set this to false, right? And enable files display to false. And then it's what Dynamo now is trying to create its geometry, and it's as usual slow. Okay. Okay, let's see what happens here. Don't crash, please. Okay, while this happens, any questions? Oh, come on.
Really cool. I wonder if that component's available for Grasshopper as well, but I think you're right, it's probably Kangaroo.
Yes, Kangaroo.
Yeah, I think I did something similar.
Oh, I think what's happening is I forgot. I was naughty and I forgot to do something. It's pushing so basically those divisions is 50. So it's pushing those 50 surfaces already into Revit. Oh, okay, I need to show the preview. Okay, the preview is coming up. Dynamo, be more like Rhino. Okay, there we go. Finally, so this is what Dynamo gives me out of that, out of Dynashape. So then I can then use this later for the work for other work I'm trying to do. So basically then I create the surface. So you can see the list here. I'll just show you the list structure. It first gives you the points. So if you want to use the points for anything, you carry on. But what I wanted is the poly curves. So if I look in here, if I go down, so here you can see the polycurves. So it gives me about 50, is it? How many polycurves? It gives me basically the polycurves on the X and the Y, right? So all I wanted was the first, I noticed the first 50 are for the Y. So I got those 50. So I'm just going to hide this preview. So I'm just going to show this. Oh, sorry, the X. So I got those 50, right? You can see the lines over here.
Mm-hmm.
So then I used that to create a loft. So I lofted those. Then after I lofted, so I flattened them because they're not, as you can see here, there's the individual lists. And to loft, you need them to all be in one list. So I flattened it. Then I created a surface by loft. If you look here in the preview, then it creates the surface I need to actually push into Revit. But the surface, if you notice, is tessellated because of the lines, right? So Revit is not going to let you push that as one thing. It would actually take each split. So what I had to do is actually explode it to create individual surfaces. If I had this preview and show it again. If I click on one here, it's not showing the color now. But you can see those numbers moving. So basically, the individual objects. Then afterwards, I remember what I told you about the anchor points. I basically took those anchor points. There's 6 anchor points, and I noticed they get placed at the end of the list. So then I got those. I used this node called take items, and I got those anchor points, as you can see over here. And then I got their directions, and then their directions were pointing upwards. Then I reversed them, and then I basically used that direction to create a line. And where is that? Line by point direction length. Okay. Then, as you can see at the bottom, can you see these lines over here? Okay, so I use those lines. Those lines are basically what I use to create the columns in Revit. Okay, so then afterwards, also I actually didn't show that. Okay. So those are the lines. You see it there. Okay, so they're following that direction. Okay, then I took that afterwards and I used this to create supports in Revit. Okay, so then that's structural framing dot column by curve. If you have Python skills, you can actually use Python to make this for Grasshopper, right? Or you can use it to make it for Dynamo as well if you want your own cost. But there's no need to that because this comes by default, right? So then when we do that, basically those columns get pasted. You see these columns, they get created in Revit along those lines. Okay, and then let me just go back into Dynamo. And then I exported each of those surfaces, those 50 surfaces, as families, mass families. And you can only do that by using this custom package called Spring Nodes. So then you need to get the conceptual mass family template. And then you need to make a name for each of those 50 surfaces. So then to do that, you need to say, count the list, how many surfaces are in that list. So you can see here, that's my list. You see, so I took that list and I got a count, 50. Then you say, this is what I wanted to name the family, market canopy surface, then plus a space, then 1 ... count. So that creates a range basically. And then it adds market canopy surface to 1, 2, 3, 4, up to 50, right? And then you plug those names into family name, right? And then afterwards, I also wanted to add You also need to say what category it is. Not really important, but you need to, I just want, so it puts it in the right category on the Revit interface. You don't want it going into generic model or something. And then I put the category in there, and then also put the material. This didn't really work. I don't know why. Then I just said canvas, and it takes the canvas material from Revit, and then it's meant to plug it in here. And then when you run, it then exports each as a mass. Well, let me just show that. VV, select all. I'm just going to show the masses. Okay. This actually, okay, so you can see the masses. So it only makes one, then I just copied it in Revit, right? It's pretty easy to do. And so here's the mass family. You can see the name is Market Canopy Surface 1. The next one will be Market Canopy Surface 2 over there, and up to 50. So the run it was taking so long to do previously it was making each one of them 1, 2, 3. So it basically runs every one. It's a run. Then it makes all 50. Then afterwards, I then apply a wall to it. I'm just undoing. Revit does not like this. Yeah, then I apply that wall to it. So I just made a new wall type with edit type, this window here. And then I just made a new type, and I just give it a thickness. So this project is in meters. So I just made this 0.01, which is 10 mil. And yeah, and that gets created. And then let me show you. So that's basically it. Then I'm just going to go into a 3D view over here, and then just show you a bit of Veras. So basically, I don't want to. Yeah, I don't want to go through the process of doing some high quality rendering or whatever. Putting in. So I just want to put in some basic blocks that indicate market stalls and whatever else. And so, but basically, you can feel the scale of the space here. You can see that. You can see this people. Maybe it's too big, but I quite like how big it is. It's about 12 meters high. It's too tall. But I wanted something pretty that people can see. You know, it's like a landmark. Yeah. Maybe it's too big, but we can. If the cost is too high, we can bring it down. Then for Veras, so you were saying something, Gerald, about Veras?
Oh yeah, I was saying then you brought it up, so you had to do a demo on Veras.
Yeah. So then basically Veras is a plugin. You just download it from the Evolve Labs website. It's AI rendering engine. Okay, then you just it just needs you to sign in. The account is actually like $6,000, so it's so cheap. I would advise anyone to just buy it for the office. The value I think you get from it is just it's immense.
Per year or something?
It's floating, so a year license. Then you'll have to put the email of the person into the account. Yeah, or else no one else, you won't be able to use it. So I'll just talk you through. I hope I'm recording all this. Hope it's not cut off. So it suck. Okay, so then it's a square image, very similar to DALL-E or Midjourney. It crops the view. It takes the current view you have, crops it up. So you probably want to make sure your view is square so it makes sense to you when it gets it. There's a thing called creativity strength. So basically, the more creative it is up here, it kind of deviates from your image. It does. So let's make it creative. I have 5 images left for trial because I'm off the office's account. Yeah. So then there's a style strength that affects. Will it take Revit's aesthetic, or will it take its kind of a more realistic aesthetic? So if I push this up, it's going to look like a more realistic image. Okay. And the width of the image, you can't change it if you are using a trial account. And the number of renderings you can't change if you're using a trial account. So if you had if you're off a trial account, you can push this probably like about 4 or something. and it does 4 renderings at once. The renderings are very fast. It's like probably max 10 seconds. Imagine doing this on Lumion. You're like, it doesn't compute.
Yeah.
And so then there's a thing here for turbo nature. Do you want lots of greenery around it? And is it an interior image? Yes. And do you want atmospheric? Atmospheric is basically, is it like hazy or like you want fog? That's what I got from that. And is it an aerial view? No. So this is not an aerial view, so I'm not going to take an aerial view. And so what I'm going to do here, I wrote a prompt previously. I just sent it to myself on WhatsApp, so I'm just going to copy it off my WhatsApp. Bayo. Okay, so I'm going to Control C. And so what I did here, I'm going to paste this prompt. I said interior of translucent white canvas market tent structure, concrete block, paved floors, afternoon sun, many people inside, trees outside, cyclists outside, artificial lights, traders at market stalls. So there are no market stalls. Yes, it's probably not going to make very good ones, but then you just go hit render and we see what happens.
What GPU do you have?
It's not rendering off my computer. It's on the server. It's cloud. So you can see here what it created. How incredible is that? And you can see
it's really cool.
And you can see how it deviated off my image. But pretty much this is how the space is going to be. I just need to add a few stalls in here, and just say maybe they're fruits on the stall or whatever. And it's going to take that and you see what it did with the people as well.
It mimics their positions.
Yes.
And then did a better job than our good Revit.
How incredible is that?
Yeah.
That is
it's pretty good.
Insane. You can use this.
It looks a bit watery on my screen.
Oh yeah, I don't know what it's doing with that. I told it concrete. I think the image from Revit is probably just not well defined. It's like tiling, so I don't know. It should have picked that up. Maybe it needs to be something more of like depth to it, so then it picks it up.
Graphically, it looks nice. It's just because I'm
Yeah, guys, that's it. Hope you like that.
That's also download this one.
It was really good. It was really good.
Thanks.
Yeah, it was really good. I think whoever's going to watch this is going to want to download Dynamo the next day. Dynashape and start doing cool stuff.
Yeah.
Like I don't think I'll be able to do that anymore because I'm looking at the time now.
It's quite long, yeah.
Yeah.
We've done a lot. Yeah, next would be Gerald. Yeah.
But this is great, guys. We need to keep this momentum.
Yeah,